Okay, guys, this is number 57. Thanks, Vicky. X naught, XF, V naught, VF, and AT. We've got two different things going on here. You have a pedestrian running to catch a bus. Thought we did this one in class, but I'll do it again. You got a pedestrian running to catch a bus, and the bus is accelerating at 1 meter per second squared. Does he make the bus? Watch how cool this is. He's 0, pedestrian. 0, final position. We know that's where they want to touch each other. His velocity is 6. He's moving with a constant speed, so his acceleration is 0. His time is, we don't know. Bus. Bus starts off at what? Rest. 0. Oh, be careful. When he is 15 minutes from the pedestrian is running at a maximum speed to catch a bus stopped at a traffic light. When he is 15 meters from the bus, the light changes uniformly at 1 meters per second squared. Does he catch the bus? Let's draw this picture. Here's the bus. He's behind the bus. He's 15 minutes away from the bus. So let's call this 0. Let's call the bus. Erase this guy. Let's say the bus is where? 15, right? Okay. The problem starts. The bus is at what? Rest. Right? We know his initial velocity is 0. We know his acceleration is what? 1. Does he make it to the bus? Let's see what happens. If so, how far does the bus have to run in order to catch it? Well, we know that the person XF equals X naught plus what? V naught AT. V naught T plus 1/2 AT squared. That tells me that X naught, and he has no acceleration, so his final position is what? V naught T. Let's see, that's for the person. XF equals, what's his initial velocity? 6t. I'm not going to write this equation down again. Well, yeah, I will. For the bus, his initial velocity is 0. He has an acceleration of, I snuck it right here, so let me move it over here so you can see it, of 1, right there, right? So you know his position equation is going to be XF. His initial position, be careful here, is what? 15, right? 15 plus, start from rest, so it should be 1/2. My A is 1, T squared. So now it should be XF equals 115 plus 0.1/2 T squared. Horrible, 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 but I gotta work what I got. Notice, when do they catch each other? They catch each other when what? Ouch, sorry. When this right guy here is what? 15. Let me see if I can write it. Now what are we going to do? Set these two guys equal to each other. This guy right here is his x final 6t. So we're going to let 6t equals what? 15 plus 1/2 t squared. Right? Because 1/2 times a 1 right here is 1/2 t squared. Now that looks a little messy. I'm gonna start a new screen. Let me go ahead and save this one. I'm gonna save it as number 57. Smooth draw. Smooth. So that way, let's see if I can remember the 6t, 15 plus 1/2 t squared. 6t equals 15 plus 1 half t squared. 6t equals 15 plus 1 half t squared. So now I'm going to give me a new page. 6t equals 15 plus what? 1 half t squared. We have a quadratic. You know Smith, the first thing he's going to do is what? Multiply everything by 2, get that 30 plus t squared. I now know that's going to be t squared equals minus 12t plus 30. Sure be nice if that factored pretty, but it doesn't, because 30 is 15, 2, 6, and 5, and it won't get that 12 for me. Equals 0. So now you have to go use who? The beast. Plus or minus square root of 12 squared, which is what? 144. I know, son. I tell you always to plug it in, but you know, I'm going to go ahead and just do it right here. So stop fussing. A is 1. Here comes my C, right? Divide by what? 2. That becomes 12 plus or minus what? Square root of 24, right? 2, which becomes your 12 plus or minus, you know, the square root of 24 should be about 4.8, 4.9. Let's check it out with the handy dandy calculator. Square root 4.9. So this is 4.9 divided by 2. So my 2 answers should be 36 point, that's 12, sorry. Let's undo that. 16.9 divided by 2, which is what? Half of 16 is 8, half of 9 is 4, 5, or let's do 12 minus 4.9, which we already know. Undo it, because I'm running out of space. It's going to be what? 8.9 divided by 2, which is horrible, 4.45. Do something special. I'm jumping over the Desmos for a second. Boom. Hey, love that guy. What's up, Vicky? Desmos. My first equation was what? F of x, the person, P of x. X is time, right? So let's let him be 6t, right? 6x, sorry. There he is. Now what happens if we let the other one be B of x? That's the bus. Equals 15 plus 1 half. Let's see if I clean that up a little bit. 0.5, which is 1 half, right? 0.5. Was it 0.5? Or was it, what was the first part? Let's go back to smooth drawer. Should have been 15 plus 1 half t squared, because he's starting from rest. There we go. Go back to Desmos, plus 0.5 t squared, right? Because the bus is what? 15 in front of him. So we got to give him that 15, right? Where's my graph? I don't see my graph. Why don't I see my graph? There he is. Yuck, yuck. Notice where he starts at, 15. Watch how cool this is. This is a position graph. So let's come up here, change this setting. Let's at x-axis, let's go from 0 to 20. Cool. Now, look what's going on here. Here comes the bus. He starts at 0, right? The guy is running with a constant speed. That is the person. Because guess what's happening here? Constant speed means what? The slope is constant, so it's 6. The slope of a distance versus time graph is the velocity. There he is. How many times does he touch him? He should touch him where? Let's see if it actually gives me the intersection. 3.51, and it says what? 21, right? 8.5. What was my math? 8.45 and 8.45, and that should have been 12. What the heck is that handwriting? 4.5, right? Because 12 minus 4.9 should be, let's erase that right here. Let's erase that. This should be 8.49. 8.4, it should be 12 minus 4, should be what? 7.10, right? 7.10 divided by 2. Check out the handy dandy calculator again just to be safe. Should be 7.10 divided by 2 equals 3.55. 7 point, yep, so we said 7.10, 3.55. So my two intersections should be 7.55, 8.45, right? Let's go back to Desmos and see how close we were. Wow, 8.5, and let's touch him right here. He's going to be what? 3.51. That's pretty slick. Now, one more thing I want to do here. What happens if I plotted this as just points? What happens if I said, let this be the point 6x x. Now let's just make this 6a comma 10, just to make a point for a second. I want a to go zero to 10. Okay. We want a to be 0 to 10. And let's step 0.1. That's my slider. Okay. Let that A go from 0 to 10. And we're going to step 0.1. Okay, play it. Whoa. Now, let's do the same thing for the bus. We're going to let the bus be a point. Let's try that again. Let's do parentheses 15 plus 0.5 a squared. Okay, comma comma 0. Notice how we have two dots. You have the green dot and you have the red dot. What happens if we hit play? Boom. Notice when they hit, the time is 3.9. Let's let them keep going. Look what happens. Let's go back to the beginning. Reset my slider. Cool. How far is the red dot in front of the green dot? 15. 15. Remember, our time should be 0 where they're going to hit each other. Now let's go back to the problem. Getting a little yucky, but stay with me. Go back to the problem. We're going to save this right here as part 2, because I think the original problem said this is part 2. The original problem said does he make the bus? Yes. If so, how far does he have to run in order to catch it? If not, how close does he get? We know he caught it, so we solved for the times already. I'm going to go back to part 2. What time does he catch the bus? He catch the bus at what? 3.55, right? Cool. And if he missed the bus that time, the bus passing by, he doesn't get to jump on it. He's got one more time to jump on it, 8.545. Let's see what that distance is. I'm going to sneak it up here, right? I know my distance can either be this equation or this equation. I'm going to use that one. I'm going to say my distance, my final position is going to be what? 6 times 3.55. I know 6 times 3 is 18. Half of 6 is 3. So I know it should be 21.30. I don't know. It can be, let's get the handy dandy out. Let's see what happens here. 6 times 3.55. Enter. 21.3. You go, boy, without that calculator. So that means at 21.3 meters, they should do what? That's where they cross. Jump back over the Desmos for a second. Look how powerful Desmos is. Pretty cool. So watch right here. If he started at 15, right? If he started at 15, I'm going to add 21.3, should be 37.3. Somebody, what is the equation of every vertical line? Hello. It's going to be x equals what? 15 plus 21 is 36.3. Okay. So my proposal is this guy here is going to start 15 meters up front. This guy right here is going to be 15 meters behind it. If I hit play on my A, they should touch at the purple line. Let's see what happens. I'm going to drag this slowly. We said it was how many seconds? 3.3. Uh-oh. We got a problem. We got a problem. Because notice he's at 3.3 right there. Makes sense. I don't know why I added that. It should be where? At 21.3. Boom. And look how cool that is. He's actually right there. Look at the dots. Boom, 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 boom. Caught him right there. Right? Let's zoom in a little bit, see what happens. Oh, hell. My bad. Here he goes right here. Now, where does he cross him at again? So he's going to catch him right there. Catch him again. Right? So this really does kind of confirm what we're doing. Sorry for the long video, but there's a lot of senses going on here. The mathematics will explain the physics. Cool. And I'm going to let this guy come back here, go to my A. I'm just going to let it bounce around 4 so you can see what's going on. See it? Starts at 0. Boom. He's accelerating. Caught him. Cool. All right. All right. All right. Thanks, Vicky.